Okay, even and odd function. This is a pretty straightforward thing to do. You can make it complicated if you're not careful, but it's pretty straightforward, easy to do. If you have a graph, it's very very simple. If it's even, the graph is symmetric over the y-axis, meaning that the y-axis is a mirror. It should go directly right down the middle, and it should fold back right onto itself. All right, the y-axis is a mirror. You can always plot points if it gives you points and um, you don't have a graph. You could always draw a graph, or if it gives you an equation, graph it in your calculator, take a look at it. If you do have points, there is a way to look at it and tell. If you have an x value and a negative x value, all right, so I have 2 and negative 2, they have to have the same y values, and they all have to. So let me do a different color. 1 and negative 1 is going to have the same y value. And then there'll be 1 point right in the middle, which is going to be a 0, which is the vertex. All right, and the vertex should be right on the y-axis. All right, but if you're not sure, plot the points and look at it, put it in your graph and look at it. Odd's a little bit harder to do, and it's hard for me to show in a video like this because I would actually take the thing and physically turn it upside down. Um, but if you spin the picture upside down 180 degrees, the graph looks exactly the same. All right, it's called origin symmetry, which is odd symmetry. I don't know why it's called odd symmetry, but that's what it's called. So that'd be an odd function. And if you take that graph and you spin it around, so if you spin this upside down, let me get an actual pen here. If you spin it upside down so that the y was pointing down like this, that graph would still look the same, all right, even though it's upside down. Okay, and that's what you do, physically spin it. If you have the numbers, again, I would probably plot them to make sure. But how it works with this is if you have an x and a negative x, the y values will just have opposite signs. All right, so 2 is 4, so negative 2 has to be negative 4. It doesn't have to be positive, positive. It could be 2, negative 4, and then negative 2, 4. All right, and again, that works for everything. So you look at the ones, and you've got that. Okay, and again, we'll have kind of a vertex. It's not really a vertex. It's an inflection point. If you take calculation on what an inflection point is, but it's an inflection point where the graph kind of spins, all right, and it changes from one thing to the other. But it has to be at the origin, all right. So that point has to be the origin. If it doesn't go through the origin, it cannot have it, all right. So I'm going to write down must go through the origin. So that's really it. You just kind of go through and look at all these things. Like I said, if it doesn't have a graph there for you, then make one. All right, then make one unless you can tell from the points itself.